Hello guys, this is Mr. Victor. We are going to lesson 3. If you are starting to learn geography for the first time and you want to do your KCSE or you would like to do geography for your final exam, this is a good channel for you. I will be covering everything. So this is Form 1, Lesson 3. I have lesson 1 and 2, so we are going to proceed from humidity where we left. This is teacher Victor. Welcome. The lesson will take 1 hour. So we talked about factors affecting temperatures or factors influencing temperatures. Now we are going to proceed to factors influencing humidity. So factors influencing humidity. So the first one, we have temperature. So we are going to list a factor, then we explain, list a factor, then we explain. So that is how we prepare ourselves for paper 1 and paper 2, where we'll be explaining things. So you'll be told you can be given factors to explain, or you can be given a factor, then you're told to explain. That is the nature, or that is the structure of many exams. So the first one, we are going to talk about temperature. How is temperature affecting humidity? So we say places with high temperature experience high humidity due to high evaporation and air having high capacity to hold moisture. The next point, how we can explain that: places with low temperatures have low humidity due to low evaporation and air having low capacity to hold moisture. So that's how we explain temperature and how it affects humidity. So number 2 is source of moisture. Source of moisture: areas near water bodies, e.g. Kisumu and Mombasa, experience high humidity due to evaporation of water from the water body. Places near thick vegetation also have high humidity due to evapotranspiration. Areas far away from water bodies, such as the middle of deserts, have low humidity. Then areas receiving heavy rainfall also have high humidity. Number 3, we are going to talk about air pressure. Air pressure as a factor affecting humidity. So we say there is high humidity at low altitude because high pressure compresses air warming. It increases its capacity to hold moisture and also causes high evaporation. There is low pressure at high altitudes because air expands and cools, thus reducing its capacity to hold moisture. Number 4 is latitude. Low latitudes experience high humidity due to high temperatures, resulting into high rates of evaporation and having high capacity to hold moisture. High altitudes experience low humidity due to temperatures resulting into low rates of evaporation and air having low capacity to hold moisture. So those are some of the factors that affect humidity. As I have said, in exams, you can be given a factor to explain, or a question can simply come: explain 4 factors influencing humidity. Explain 2 factors influencing humidity, or explain how the following factors influence humidity. So that is the nature of the question. So that's how that area, a question can be set in that area. So in significance of humidity or moisture, what are the significance? What are the importance of humidity? What are the importance or significance of humidity? Number 1, affects rain formation in such a way that places with high humidity are likely to experience higher rainfall than those with low humidity. Affects rain formation in such a way that places with high humidity are likely to experience higher rainfall than those with low humidity. Number 2, regulates the heat loss from the Earth's surface by absorbing terrestrial radiation. Regulates the heat loss from the Earth's surface by absorbing terrestrial radiation. Number 3. Sorry, I've lost it. Number 3. Number 3, we are going to talk about we have talked about air pressure. Number 3, we are going to talk about it affects sensible temperature. It affects sensible temperature in that the higher the humidity, the more we experience sensible temperature. It affects sensible temperature in that the higher the humidity, the more we experience sensible temperature. Let's move to precipitation. What is precipitation? The forms in which the Earth's surface receives moisture. So precipitation is just the form in which the Earth's surface receives moisture. So forms of precipitation, we are going to discuss forms of precipitation. A question is very important. A question can be set in this: forms of precipitation. List forms of precipitation, or you can be told to explain forms of precipitation, explain 4 forms of precipitation, or you can be given a form of precipitation that you are told to explain. Kindly take note of that. I am going to do exactly that. So the first one is snow. Snow as a form of precipitation. So what is snow? Solid precipitation formed when tiny water droplets freeze and form ice crystals. So that is snow. It is a solid precipitation formed when tiny water droplets freeze and form ice crystals. The crystals may fuse to form flakes. Number 2, we have sleet. Sleet is a form of precipitation which is a mixture of rain and snow. So sleet is a form of precipitation which is a mixture of rain and snow. Number 3, hail. Hail, Hail. These are roughly spherical lumps of ice formed when supercooled clouds droplets mold themselves around ice crystals before cooling. It destroys crops, life, and house roofs. So there are spherical lumps of ice formed when the supercooled cloud droplets molds themselves around ice crystals before cooling, and it destroys crop lives and house roofs. Dew. So what is dew? Dew is a precipitation consisting of water droplets formed on cold surfaces at night, e.g. iron roofs and glass blades. So how is dew formed? In a clear night, there is a high ground radiation. Temperature on the Earth's surface fall below dew point. What is dew point? Temperature at which air being cool becomes saturated. So that is, if you're told to define what a dew point is, it is a temperature at which the air becomes saturated. Then excess water condensed on the surfaces. on the surfaces. So that's how dew is formed. Number 5 is rain as a form of precipitation. Rain as a form of precipitation. So precipitation consisting of water droplets. So this is a precipitation consisting of water droplets formed when tiny water droplets merge around particles of matter and becomes heavy and fall down to the earth. So condensation. So let's move to condensation. We have discussed 5 forms of precipitation. Don't forget that. Now we are moving to condensation. So what is condensation? Condensation is the turning of water vapor into tiny water droplets as cooling continues below the dew point. Remember, we have defined what dew point is. The droplets join to form clouds. So the droplets join to form cloud. What are some of the causes of condensation? Causes of condensation. Number 1, we are going to talk about diabatic cooling. Cooling of moist air as it rises vertically. So that is a diabatic cooling of moist air as it rises vertically. Orographic cooling. What is orographic cooling? Cooling of moist air as it climbs a hill or mountain. Then we have frontal cooling. What is frontal cooling? Cooling of warm air mass when it blows towards a cold air mass. Then we are going to talk about advection cooling. What is advection cooling? It is cooling as a result of moist air moving over a cool land or sea. So those are some of the causes of condensation. If you are told in exam to discuss causes of condensation, we have talked about them. There are 4. We have talked about adiabatic cooling, orographic cooling, frontal cooling, and advection cooling. Don't forget that. How condensation takes place? How is cloud formed? So how condensation takes place? Number 1. Point 1. Moist air rises to the condensation level, that is altitude where temperature is below dew point. It is cooled below dew point. Tiny water droplets condense around tiny particles such as dust, smoke, and pollen grains, and salt particles. The droplets merge and eventually become bigger and falls as rain. If the moisture rises to an altitude where temperature is below 0 degrees Celsius, the condensed water droplets freeze, forming ice particles. Or supercooled water. The supercooled cloud droplets may mold themselves around ice crystals before freezing to form hail. Remember, hail is a form of precipitation we have just discussed above. Don't forget types of rainfall. What are the types of rainfall? We have relief type of rainfall, also called orography, also called mountain rainfall. From the diagram you can see we have relief rainfall. So from the diagram you can see you have the moist air cools as it rises windward side, then cloud formation, then you have orographic rainfall, then you have mountain, then you have descending air, then you have leeward side. So that is the rain shadow. Rain experienced on the windward slope rain experienced on the windward slopes of a mountain or hill formed when the moist is forced to rise over a mountain or a hill. You can see moist air cools as it rises. How it forms. How does relief rainfall forms? Moist air is forced to rise over a hill. The temperature and air pressure decreases, making it to expand. Air cools due to decreased temperature and pressure. Air cools due to decreased temperature and pressure, causing it to expand. Moisture condenses, forming tiny water droplets or clouds. The tiny water droplets in clouds merge and become too heavy to be suspended in air and fall as rain. Air proceeds to the leeward side with low moisture content. Since it is heavier to being cool, it descends over that side and gets warm, making it to hold onto the little moisture it had, causing the side to receive low rainfall. So that is the rain shadow leeward side we have talked about. Number 2 is convectional rainfall. Remember, we are talking about types of rainfall. We have said relief, also called orographic or mountain. Number 2, we are going to talk about convectional rainfall. Convectional rainfall, as from the diagram you can see, you have rising moist air, then you have convectional, you have cloud, then rising moist air. So type of rainfall common near, so this type of rainfall is common near water bodies formed as a result of convective rising and cooling of the moist air. It is accompanied by thunderstorm. Remember, it is accompanied by thunderstorm. So how is convectional rainfall formed? Ground or water body is heated, causing evaporation. There is a convective rising and cooling of the moist air. Condensation takes place, forming tiny water droplets. The droplets merge and fall as a rain. The cool, dry air descends to the surface where it is heated and its capacity to hold the moisture is increased. The process is repeated. Number 3 form type of rainfall is frontal, also called cyclonic rainfall. Frontal, also called cyclonic rainfall. Don't forget, we are talking about types of rainfall. From the diagram you can see warm air, you can see frontline, cool air, then you have clouds. This type of rainfall is common in mid-latitude areas, formed when air blows towards a cold area or when the air mass meets with the cold air mass. It is accompanied by cyclones. What are cyclones? These are violent winds. How is cyclonic rainfall formed or frontal rainfall formed? How is cyclonic rainfall formed? Warm moist air meets with cold air mass. The warm air is forced to rise as it is less dense. It cools as it rises at the line of the contact with the cold air. The moisture condenses, forming clouds resulting in frontal rain. The moisture condenses, forming clouds resulting in frontal rain. So those are the 3 types of rainfall we have talked about. We have talked about frontal or cyclonic rainfall, convectional rainfall, relief rainfall, which is also called orographic rainfall. Remember that we have talked about them. Factors influencing rainfall types and amounts. What are some of the factors influencing rainfall types and amount? As I've said, this can be set in different ways. You can be given a factor you are told to explain, or you can be told to state and explain factors influencing rainfall types, and that is how it is being set. Kindly have that in mind as you go through, or as you read, or as you prepare yourselves for examination. Number 1, relief or topography. What is relief? What is topography? Relief features such as mountains and hills results in the rising and cooling of moist winds to form relief rainfall. Number 2, aspect. Windward slopes, which are on the path of rain-bearing winds, receive heavier rainfall than leeward slopes, which face away. Windward slopes, which are on the path of the rain-bearing winds, receive heavier rainfall than leeward slopes, which face away. Number 2 is forest and water bodies. Areas near forests and large water bodies experience higher rainfall and more often due to high rate of evaporation. Number 4 is air pressure. High pressure areas receive low rainfall than low pressure areas due to pushing of air masses from high pressure to low pressure. The high pressure areas have a descending dry wind or dry air. Air masses. When warm and cold air masses meet, frontal rainfall is formed. Air masses. So that you have air pressure and you have air mass. Then you have ocean currents. How does ocean current affect the formation of the rainfall? It influences rainfall where coasts washed by warm ocean currents experience heavy rainfall when moist onshore winds are warmed by the current and made to hold onto moisture which they release on reaching the land. The coast washed by cold ocean currents, on the other side, experience low rainfall as a result of moist winds being cooled and moisture in them condensed, resulting in rain falling over the ocean, thereby bringing little or no rain to the coastal areas. This is coast of western margin deserts, e.g. we have Kalahari and Namib deserts. The next thing we are going to talk about is atmospheric pressure. Atmospheric pressure. We define what atmospheric pressure is in the second lesson. You can go and check. If you have not watched that, you can have a look to understand what is going on. So we're going to talk about factors affecting atmospheric pressure. The story continues. The same structure of this particular question. A question on atmospheric pressure can be set just as the same as what I've talked about rainfall and temperature humidity. So a factor can be given, we are told to explain, or we are told to state factors affecting or influencing atmospheric pressure. Number 1 is altitude. How does altitude affect atmospheric pressure? Pressure decreases with increase in altitude because the column of air becomes shorter, hence it exerts less weight direct. Number 2, temperature. How does temperature influence atmospheric pressure? When air is heated, it expands and exerts pressure over a large area, resulting in reduced pressure. From your physics knowledge, you know that when an air is heated, it expands and exerts more pressure over a large area, resulting to reduced what? Pressure. When it cools, when it is cooled, it contracts, exerts pressure over a small area, resulting to increased pressure. Number 3 is rotation of the earth. How is rotation of the earth affecting atmospheric pressure? We say rotation pushes air masses from poles towards the equator, causing air to spread out and occupy more space, causing it to expand, making pressure to decrease. When air from the equator moves towards the poles, it occupies less space, causing it to contract, resulting into high pressure. So those are the factors influencing atmospheric pressure. Therefore, we have talked about altitude, temperature, rotation of the earth. There are 3: altitude, temperature, rotation of the earth. In exam, if you are given a factor to explain, that is how you're supposed to explain. If you're told to state and explain, that is how you're supposed to do that. Let's move to mist and fog. What is mist? What is fog? Fog, you have seen it every day. I would have said it in my mother tongue language, but I have remembered I am not speaking to a specific group. I am teaching the whole community. So mist and fog are a mass of tiny water droplets suspended in the lower layer of the atmosphere. Fog is denser than mist, i.e., that is, has more moisture. Both hinder visibility, although fog reduces visibility to less than a kilometer. When fog mixes with smoke, it forms smog. How are mist and fog formed? How do we form mist and fog? How are they formed? Moist air cools below the dew point. I have described what the dew point is. I don't like repeating myself, but as a student, you're supposed to remember what dew point is. So, moist air cools below the dew point. Condensation takes place. The resultant water droplets remain suspended in the air. Let's talk about types of fogs. What are the types of fogs? In Form 1, you will be asked. In Form 4, you will be asked. In Form 3, Form 2, you can be asked. In mock, pre-mock, post-mock, you can be asked this question. Types of fog. What are the types of fog? We have radiation fog. What is radiation fog? This is a type of fog formed when moist air is cooled below the dew point as a result of intense radiation on the ground at night. Number 2, we have adventitious fog. This is a type of fog formed when moist air from the sea moves horizontally over a cold surface, e.g., we have snow-covered ground. We have orographic fog, also called hill or upslope fog. Don't forget that. Orographic, also called hill or upslope fog. This type of fog is formed when moist air is cooled after climbing a hill or a mountain. Evaporation fog. This is a type of fog which is formed when water vapor is added to cold air that is already near saturation, causing excess water vapor to condense and form fog. Another type of fog is frontal fog. Type of fog formed when warm, moist air is cooled below as it rises over cold air mass. Then the very last one, the second last one, we are going to talk about steam fog. What is steam fog? Formed when moist air passes over the surface of a much warmer freshwater body. The warm water is cooled from above and condensing water vapor forms fog. It appears to be steamy. Ice fog. Ice fog. This is a type of fog formed when water vapor is converted into ice crystals when temperatures are below freezing point. We are going to talk about clouds now. This is also another important question being set in KCSE internal exams. In every exam you'll be doing of geography, you can have a question on clouds. What are clouds? Are a mass of tiny droplets or ice particles formed when water vapor condenses. There are three types of cloud. You have cirriform, you have stratiform, then you have cumuliform. So let's start with the first one, cirriform. Thin and wispy clouds composed of ice crystals. Those are cirriform. Stratiform appears as grey sheets covering most of the sky and are rarely broken into units. Cumuliforms are massive, rounded, with flat base and limited horizontal extent below upward to great heights. Basic cloud types. What are the cloud types? Don't confuse these things. 3. We have cloud forms. We have talked about cirriform, stratiform, and cumuliform. Now we are going to talk about the types of clouds. We have stratus cloud, we have nimbus cloud, cirrocumulus cloud, we have nimbostratus, we have cumulus clouds, then we have altocumulus clouds. These are basic cloud types. Kindly don't confuse the two. Number 1. Stratus clouds are found in layers, are flat in shape, and resembles fog. Number 2. Nimbus clouds are dark at the base, sometimes white at the sides, and causes rain and thunderstorm. Cirrocumulus are white clouds consisting of ice crystals. Nimbostratus clouds, a rain cloud which is dark gray, spreads over the sky in slow uniform layers. You have cumulus clouds with a flat horizontal base, massive, rounded, and less horizontal extent. Then we have altocumulus clouds. These are high clouds composed of ice crystals which indicate fair weather. We are moving next to world distribution of pressure zones and the planetary winds system or wind prevailing winds. So the first one is equatorial low pressure. Equatorial low pressure found between 23.5 degrees north and 23 degrees south. Experience high pressure, a zone of low pressure and doldrums, zones where southeast and northeast trade winds converge, associated with convectional and thunderstorm, migrates to the north with the apparent movement of overhead sun. We move to the subtropical high pressure zones. We say they are found within 30 degrees north and 30 degrees south, a zone of high pressure, a region of calm descending air, source of trade winds and westerlies, zone of divergence of trade winds and westerlies. We move to the next one is the temperate low pressure zone. The temperate low pressure zone found within 60 degrees north and 60 degrees south, a low pressure zone, the zone of convergence of westerlies and polar easterlies. Kindly take a note on the diagram. Very important. a diagram will be given to you in exams like this, then you'll be told to name the zones. Kindly take a note of the diagram, very important. I am insisting, kindly take a note on the diagram, look at the diagram keenly. You can pause the video, draw the diagram with the labeling. Let's move to the polar high pressure zones. The polar high pressure zones found over the poles 90 degrees north and 90 degrees south. A high pressure zone of descending calm air of low temperature, source of polar easteries. Let's move to the world's prevailing winds. These are the major winds blowing over the earth frequently and consistently, and which influence the world weather. So the first one, we have trade winds. What are trade winds? Blow from subtropical high pressure zone and blow to the equatorial low pressure belt. Number 2, westerlies originate from the subtropical high pressure zone and below to the temperate low pressure belt. We have polar easterlies originate from the polar high pressure zone and blow to the temperate low pressure zone. Kindly remember that. We have monsoon winds, seasonal winds which reverse in the direction of flow. They blow towards the land during summer, that is onshore, and from the land during winter, that is offshore. Bring heavy rains when onshore, which can cause severe flooding. Well developed in the Indian subcontinent. Then you have China, Japan, and Southeast Asia. Air masses, distinct large parcels of air moving in one direction, originate from areas of uniform weather and topography, from where they derive their characteristics. Flat areas. You have characteristics of air masses. What are the characteristics of air masses? Another question. What are the characteristics of air masses? Number 1, a large volume of air covers an extensive area, has uniform temperature and humidity, distinct from the surrounding air, retains its characteristics when it moves away. That is it. Types of air masses. What are the types of air masses? Number 1, we have equatorial air mass. Originates from equatorial oceans. It is hot and unstable. Number 2, subtropical air mass. Forms near subtropical air pressure belt. Number 3, polar air mass. Forms near poles or temperate low pressure zones. It is cool. Number 4, Arctic or Antarctic air mass. Arctic and Antarctic air masses forms over the ice sheets of Greenland and Antarctica respectively. Effects of air masses on weather. Effects of air masses on. What are the effects of air masses on weather? When warm moist air mass and cool air mass meet, cyclonic rainfall is formed. We have talked about types of rainfall. Cyclonic rainfall is also called what? Yes, as a student you have remembered, e.g. tropical, maritime and polar maritime. The next effect of air masses on weather: cool air masses take cooling effect to the areas they move to, e.g. polar continental. Number 3, if they are warm, they take warming influence to the area they move to, e.g. tropical continental. Pressure systems in the world. We will continue from pressure systems in the world. Kindly subscribe to my channel. I am Teacher Victor. Have a nice time.